Welcome, everyone. My name is Jordi Ricard, and it's a pleasure to introduce a new webinar from our ClearPix consultants. Today, we will start a new series of 3 episodes about Microsoft Fabric covering architecture, security, and data governance. I will start with a quick introduction about ClearPix and hand over to my colleague Manuel to present the content of today's session. ClearPix is a consulting company based in Barcelona and founded in the year 2000. And we've joined our efforts as part of the Sinver Group with 6 other leading companies across Europe to become the largest full-service data and analytics consultancy group in Europe, with over 500 consultants in our offices distributed in Spain, Germany, UK, Switzerland, Croatia, Middle East, Portugal, and US. We are experts in everything related to data, supporting corporations across multiple verticals with high-quality deliverables and honest and transparent partnership with our customers that usually makes us proud of the length of our engagements. We are organized around 5 practice areas: a modern business intelligence team working on data ingestion into data platforms, a data modeling layer based on the business requirements and priorities, and data visualization components through the multiple tools available on the market. Having skilled professionals, consultants working with Microsoft technology for the last 20 years, we've gone together through all the journey to the cloud with Azure, Synapse, and now Fabric. Our Big Data and Cloud practice will handle the public cloud deployments on AWS platform, Google Cloud, or Azure architectures, covering all the cloud enablement and optimization journey, as well as big data deployments with Cloudera and the Hadoop ecosystem, as well as projects where real-time and data streaming is required with tools like Nifi. An excellent team of combined data engineers and data scientists profiles are grouped in our advanced analytics practice, being able to help on the advanced analytics use cases analysis and implementations, with the tools available in the major data platforms like Azure ML, AWS SageMaker, or other tools like NIME or DataEco. Our team of full-stack engineers are able to develop web and mobile applications related to data projects, either to ingest or create API services to exchange data, embed the visual contents into corporate tools or frameworks, or developing tailored solutions to the business requirements to access the information like our executive analytics solution, Observation Deck, that I strongly recommend you check in our website. If the challenge is on the data quality, strategy, and data governance, we also have experts with the leading technologies in that space to support your initiatives and ensure the success of these key projects in today's data world. All of us available to help you achieving your business goals and objectives, making better decisions by having access to trustful and meaningful data on your fingertips. We are proud of our partnership with Microsoft being solutions partner for data and AI and Azure specializations, with a large pool of certified consultants across the different Azure Stack tools. Since Fabric announcement over a year ago, our team has been working on it with real customer production deployments and assessing the benefits that could be leveraged by our customers. With that, it's my pleasure to hand over the session to Manuel, Principal Consultant in our Microsoft Azure and Fabric team. The floor is yours, Manuel.
Okay, thank you very much, Jordi. Hi, everybody. Welcome to this first episode in the Architect Data Solutions with Microsoft series. I am Manuel Mas, the Principal Consultant and Data Architect at ClearPix, and my specialty is architecting Microsoft Azure solutions. The episode 1 aims to understand the different options and tools used to build a data solution using Microsoft Fabric. At the same time, we will focus on the need to use accelerators to build scalable, adaptable, flexible, and reliable large-scale or not so large data copy pipelines. In the episode 2, we will talk about securing our data solutions and the different ways to organize our data solution as well. And in the last episode 3, we will talk about data governance and discovery with Purview. We are going to explain here in this slide the common data lakehouse phases to build a data lakehouse. These are not specific for Microsoft Fabric. This is for any vendor. So we find that all the data lakehouse solutions contain these phases. Okay, so we have to be sure which phases do we need. The first one is the ingest. Okay, so a data lakehouse can handle any type of data from many sources. The data may vary in size, speed, and type. It can be unstructured, semi-structured, or relational. It can come in batches or via real-time, streaming. It can come in small files, massive ones. So here we will develop the ELT processes to copy this data from the source system into a raw layer, called also bronze layer of the data lake. The next one is the store, where a data lake, as you know, is just storage. Storing all the data in a data lake will result in a single version of the through and will allow end users to access it no matter where they are, as long as they have connection to the cloud. The third one is the transform. In this step, here we use compute resources to transform all the files from the raw layer to the Delta format. Then we usually enrich and clean. This is for the silver layer. And finally, we curate the data for performance or ease of use, okay? The typical joins and aggregations, for instance. Finally, we will write it to the presentation layer, the gold layer in the data lake. And we might need more or fewer layers in the data lake, depending on the size, the speed, and the type of your data. But the most common is having these three layers. The fourth phase is the model one, reporting directly from the data in the data lake can be confusing for end users. Okay, it is possible, but for business user can be confusing. Why? Because these business users are used to the relational data warehouses. Okay, so Delta Lake is a file folder system, so it doesn't provide any context for what the data is. Also, defined relationship doesn't exist with the Delta Lake. It's in its own isolated island, so you need to create a service layer on top of the Delta Lake to tie the metadata directly to the data. To help end users understand the data, you will likely want to present it in a relational data model. So that makes what you are building a relational service layer. The relational service layer is usually a semantic model. And the last one is the visualized phase. Okay, so once the relational service layer exposes the data in any and easy to understand format, end users can easily analyze the data using familiar tools to create reports and dashboards. We are going to see a high-level view of a data solution architecture. So in this session, as you know, we are going to use Microsoft Fabric as the data platform. As you can see here, Microsoft Fabric uses a data lakehouse architecture, which means it does not use a relational data warehouse. Okay, so there is a separation between the storage and the engine. So, and instead, it uses only a data lake to store the data. Data is stored in Delta Lake format so that the data lake acquires relational data warehouse-like features. Okay, so returning to the phases, we have explained the different phases in the previous slide. So here you can see in the ingestion that we will use the copy activity tool in the pipelines. Is the most typical user scenario. Okay, we don't need to code, and it presents great performance. Okay, so notebooks and data flows are also valid options with its pros and cons. Okay, then regarding to the storage in Fabric, one lake is used for the data lake. Okay, under the scenes there is Azure Data Lake Storage Generation 2. Okay? In reality, one lake is based on ADLS. Also, we have other options like Fabric shortcuts, okay, that can be used to access data sources outside of one lake, and mirroring also that can be used to copy data from data sources into one lake in near real time, such as Snowflake, a shared SQL database, okay? And in the future, we will have more options to add. Regarding to the transform, within all the layers, the data can either be stored in Fabric Lakehouse or Warehouse. Okay, so we have the different options we can choose. We can choose a Lakehouse, we can choose a Warehouse. We are going to explain in the next slide the difference, and we are going to demo one pattern where we are going to use a combination of lakehouses and a warehouse. Okay. For the compute required to transport the data, you can use features such as data flow generation 2, Spark notebooks, or we can use T-SQL and use a store processing, okay, like in a traditional BI solution. Here is where Fabric is very flexible, depending on the skills of your team and the complexity and volume of the data transformation. You have a tool just to choose, okay? You have to evaluate the needs, and you can choose any of the available tools, okay? Which is the better that fits to your needs. The next phase, the model and share, we will develop our semantic model with the business logic needed to visualize the data in the next step. We explain and compare in other episode the difference between direct lake and import mode. So if you haven't seen this interesting session where we explain in a deep technical, we do a deep technical comparison between the two modes. Okay, don't miss the episode we previously published in our YouTube channel. And the final layer is the visualize, okay, that in Fabric, we would use Power BI because it's integrated inside Fabric. So we would use Power BI for building reports and dashboards. And we have the option also to connect, use third-party apps like our observation deck product, which offers extended capabilities to consume the data. Okay, so let's talk about patterns. Okay, where here is where the warehouse and the lakehouse solutions play a fundamental role. We are presenting here two patterns. The first one is creating each zone as a lakehouse. Okay, so everything is inside a workspace, and here we put the different layers creating lakehouses. The other pattern is that we suggest creating the bronze and silver zones as lakehouses and the gold zone as the data warehouse. Okay. Regarding to the workspace organization, we will talk in the next episode about this, but depending on the specs and the different requirements of the project, perhaps you need to create the different layers and separate them in different workspaces. Okay. This approach provides you with more control and better governance at the zone level. Okay? If you put everything in a workspace, it will be a more simple solution. Okay? For the bronze layer, here we recommend using a lakehouse, and you can store the data in its original format. So whenever it's possible, keep the data in its original format. Then for the silver and gold zones, we recommend that you use the delta tables because of the extra capabilities and performance enhancements they provide. So this is because Fabric standardizes on delta lake format, and by default, every engine in Fabric writes data in this format. Okay, so these engines use the V-order write time optimization to the packet file format. Okay, so this enables extremely fast reads by Fabric compute engines. And at the end, the difference between two patterns is the gold layer. Okay, so we have created here a lakehouse. The gold layer is created using a lakehouse, and in the pattern 2, we use a warehouse. Okay, the warehouse is more focused, as its name says, is focused for more traditional data warehouse. Okay, for fact and dimension, and primarily focuses on the use of Transact SQL. And finally, the lakehouse, if you use a lakehouse, is more focused on using Spark. Okay. So here it is important to know the differences between the warehouse and the lakehouse. Both of them are use open data formats, okay, data packets. Both use the lake-centric approach and have some cross functionality. The reality is the lakehouse in Fabric is totally open, and there is no consistency guarantee. at all, even for a single table. All you need is to have the proper access to the workspace, which gives you access to the storage level. Okay? Similar to the behavior in SQL Server, okay? The transactions allow you to control the commit or rollback of read and write queries in the warehouse. So here the warehouse has these transactional capabilities. They are better for data warehouse scenarios. Then we have also two different endpoints, okay? The warehouse contains only one endpoint where you use it like SQL Server as well. On the other hand, there is the Lakehouse endpoint, okay, where we will use the Spark runtimes and library. And at the same time, Fabric provides us a SQL Analytics endpoint of the Lakehouse, okay? But be careful because the difference between this SQL Analytics endpoint and the data warehouse endpoint is that this is read-only, okay? This means that you cannot manipulate the data. You can only read the data through this SQL Analytics endpoint, okay? So this is the main difference. Then, regarding to the types of data store, as I have explained before, the data warehouse will work only with structured data. Okay, so the data is organized in a traditional way by databases, schemas, and tables. On the other hand, the Lakehouse is also used for structured data, but also is good for unstructured and semi-structured data. Okay, so the data is organized by folder and files, lake databases and delta tables. And regarding to the security, this is also something important, okay, that we will talk deeper in the next session. In the next episode, the data warehouse inherits the SQL Server security. Okay, so we have the object level, the column level, row level, and data masking techniques to secure the data. While the Lakehouse, we don't have known for Spark. You have access to the Lakehouse. You don't have, you cannot set up any security. But in the SQL Analytics endpoint that it is read-only, you can only set the row level and table level security. Okay, these are the main differences. This is one of the most interesting points here, the accelerators. One of the challenges that data engineers must deal with is developing a data solution with agility and speed. Moreover, we need to be scalable, adaptable, flexible, and reliable. Okay? So in scenarios where we need to ingest hundreds or even thousands of data objects, tables, files, okay? Developing data integration packages or pipelines for each data object becomes, let's name it a hell. Okay, it's kind of hell because you have a high number of artifacts, repetitive tasks. We usually have human errors, and even worse, we can have the situation where the schema of data objects usually changes over time. So we must maintain the existing solution. So in this session, we are going to demo data solution using Fabric with a metadata utility or framework as an example of accelerator. Okay, so why using accelerator? No, we have faster development. We gain time to focus on what is important for BI. This is get the correct answers for the business questions. Better quality, we reduce the human errors and repetitive tasks, and build adaptable and flexible solutions to success in applying, for instance, agile methodology. We can gain this option. And the last one is the easy maintenance. Our solution is simple. We provide simplicity to facilitate maintenance and troubleshooting. Now we can begin the demo. Okay, so let's begin. I have created a workspace named Medallion demo. This is created under a capacity, under a fabric capacity. Okay? In this case, it's a trial. And here we can see this flow task, okay, that and this structure using the different folders. Okay, so we are going to build our solution. We are going to connect to a source ingestion. We are going to do a data source ingestion. We are using the AdventureWorks database sample from Microsoft, okay, as a data source. Now Fabric data pipelines can connect to on-premises as well. So we can connect to any cloud or data source, in this case, the cloud source. We are going to store this to ingest all the tables here in the bronze data using our metadata solution that I am going to demo. Then we are going to build a silver layer virtualization. Okay, so this virtual layer virtualization, we are going to see it in to store in a silver layer. The next phase, we are going to do the transformation to do the ETL, okay, the data warehouse ETL to populate our golden data, okay? So this is our warehouse destination. And finally, we will build a semantic model and a report to visualize our data, okay? So this is an end-to-end solution that we are going to build from scratch, okay? So before doing the source ingestion, okay, here is where we will use the metadata. And what is the metadata? As you can see here, I am working with the AdventureWorks database. It has lots of tables here. And here we are extracting all the tables that we are going to extract, okay, that we want to ingest. If I execute this query, you will see that there are 62 tables that we are going to ingest into Fabric. Okay. Here I create here the insert query. So in the next step, we are doing this manually for this demo purposes. Okay, but this can be automated. Okay, so what we have created here in the Microsoft Fabric workspace, here we have the different layers. So we have created a metadata framework warehouse, okay, where we have a main control table. Okay, so this main control table contains basically the source table, the destination tables, okay, and some metadata information that we are going to use to ingest the data. Okay, so here we are going to ingest to insert in our metadata table the 62 tables that we are going to ingest in our bronze layer. Okay, so we are going to this metadata that we have inserted in this table is going to be consumed from a data pipeline. And this parameterized pipeline with only one pipeline and with only one copy activity, we are going to ingest. Okay, so this is the source database, source schema, source table, and the destination. Okay, so the sync database is the bronze layer, and the sync table. Here we can see the different sync tables. Okay, here we can choose a pattern. Okay, we can develop the different patterns. In this case, it's a full pattern. Regarding to this, we can have different patterns. For instance, the incremental, the change data capture. Okay, so these are different patterns that we can configure our framework to have all these patterns. Okay, so let's put this pipeline to run because it's going to take some time, and at the same time that it is running, okay, I am going to explain you how we are doing this part. Okay, so let's deactivate this silver virtualization. So we are going to ingest now. We are going to ingest all the tables from the metadata. What it is doing this framework is, okay, here is getting the tables, is reading the table from our table from here, is reading all this data to ingest the 62 tables in our bronze layer. Okay, So as you can see here, it has read all the 62 tables. We can see the output. All the metadata from the tables is being read. Okay, so all these tables are going to be ingested into the bronze layer. We can see that here there is it's invoking one only pipeline. So you can see here it is running. We can go to the source ingestion. So we have only one pipeline to do this. That's all to you. You don't need to develop. And here we have the different patterns. Okay, we have the full pattern and also the logic to do an incremental. Okay, so we could develop more patterns like the CDC, change data capture, or whatever. But here we can see that with only one copy activity, that is reading the parameterized data that is arriving from our metadata table. Okay, so it is processing with only one copy activity. We are ingesting 62 tables. Okay, this can be done also for files and for other data sources. Okay, that we can imagine. This kind of framework is very flexible and we can adapt to our needs. Okay, let's return to the execution, because you will see here that it is succeeding. Okay, it is ingesting our data. If I return to here to Management Studio, we will see our Lakehouse bronze layer. We will see that this data, the tables are being ingested here. Okay, so we can see here this using the SQL endpoint. We can see that this is like a SQL Server here, as you know. But behind the scenes, these tables contain the Parquet files, okay, with the Delta format. Okay, so we are querying this. We don't see that, we don't know that behind this is a relational store or a data lake. As you see, we don't know. We are abstracted from that information. And here, if we open again the bronze Lakehouse, we will see, let's refresh. And we will see here the different tables that are being ingested, okay? And we have the option here to view the files, okay? So here we have the option to view the files. So the underlying data are Parquet files, okay? So we are good for the first phase. We have the ingestion, we have our bronze layer that is being populated. And while this finishes, we are going to talk about the virtualization of the silver layer. Okay, what is a virtualization? Basically, what we are going to do, as you can see here, this could be a bronze silver layer, okay, because the tables are being replicated. But you can see here that all the data types are not optimized. Okay, this is there are bar charts, daytime. Okay, now perhaps we need to adapt all these bar charts to be, let's say, data types more adapted to the reality. Okay, to what they look like. Okay, so here what we have done with the metadata. Okay, we have extracted all the AdventureWorks metadata in a table. And what we are going to do is to format the data in the data lake, okay, with the same format that's from the data source. Okay, so this means that if I have a bar chart 8000 now in the Lakehouse, but the original data was a bar chart 2250, okay, we are going to put the same data type as the data source. Okay, so we are giving this kind of format. We are not going to ingest the data again. Okay, so this is why it is very flexible, because the data is, in this case, is very small. We can virtualize this silver layer, and we don't need to store the data again. So what we are going to do is just we are going to create some views that are going to format the data. We are going to select the tables and we are going to give the format. We could also add words to exclude some data. Okay, so it cleans the data, excludes some data. So this is the purpose of the silver layer. Okay, so for this demo, we are going to simplify it. Okay, so if we return to our demo, let me explain to you this virtualization, what it does. Okay, so this silver layer virtualization is the next step. And as you can see here, this is the copy activity for the source data. This is all the metadata that is coming from the data source, from the adventure works. Okay, for each table name, for each column, we extract all the metadata. So what we are going to do is we are going to get the tables for the silver layer and create views for each of the tables. Okay, we are going to automate this phase, and we are not going to develop 62 views. Okay, so using metadata, we are going to do this. Let's go. Let's insert the metadata. Let's go here and let's do this. Okay, so what we are going to do is in our metadata solution table, we have inserted all the tables that we want to ingest. So we are going to ingest to generate all the views. Okay. So here via metadata, we are generating the source table and we are generating a view for all the entities. Okay, with this specific format. Let me insert this. So this is going to insert 62 rows. Okay, and in this phase, we are going to run this. Okay, this is going to iterate through our metadata table. It is going to read all the tables that it is going to process. Here, as you can see, we will see the output, the 62 tables, okay, all the metadata. And in the next step, despite this, this is a Lakehouse, okay, we can create SQL views to give format to our data. Okay, so as you can see here, I have created in the silver layer a store procedure that is dynamically creating all the silver views. We are going to see the code here. Is creating all these silver view dynamically. Okay, so here, give me the source database and the source table, and it is going to read all the metadata from our solution. Okay, and is going to create. So here we do some data type conversions that are not compatible with Fabric SQL endpoints. So for instance, the geography and the XML, we are going to convert to a varchar max, okay? The date times, the varchar, okay? So we are converting this kind of data. If I refresh here, we will see all the views appearing. So if I open any table, as you can see, for instance, the department, you see that all the views are being created automatically, okay? So we are querying our Lakehouse through views where now we don't see the varchar 8000, now we see a varchar 50, okay? So this is more optimized for the next layer that we will build. So here you can see all these views. So we have this kind of virtualization. We don't have tables here, we don't have physical tables, but this is very flexible, okay? This doesn't mean a silver layer doesn't have to contain. This is only for this demo purpose, okay? So here we can see a table. So let's go to the next layer. It has run successfully. Okay, let's close this. Let's return. So we are now here. We have the silver data. Okay, we have this silver layer ready with this data clean and transformed, clean and formatted. Sorry, and now it's time for populating our gold layer. Okay, for our gold layer, we have chosen a warehouse artifact. Okay, it is for the golden data is a warehouse. As you can see, it has only the SQL endpoint here. And for this gold layer, what we are going to do is we are going to process. Here we have to develop the star schema. We have to do this manually, okay, because we are going to build the dimensions and the fact tables. So let me show how to do this, how we have done this. Let's go here. I have opened this. So we have here, we are in the silver layer, and we are querying all the views that we have created before, okay? So for the DIM product, this is an example. We are going to execute this, this query that is joining the product. So it has a transport. Let me execute again. The silver layer, execute. Okay, so we see here we are joining the product with the descriptions, and we are doing this kind of dimensional modeling. Okay, so we are transforming team salesperson, we are joining different entities from the source table to generate our dimension. Okay, the team salesperson, the DIM sales territory, the DIM customer. Okay, so we are joining the different tables to get the different customers. So we are going to build these data warehouse views that that will populate our goal layer. Finally, we have a fact sales table where we will add some calculated column and some logic and treatment of the null, okay, or unknown. In this case, if we have an unknown product, we will put a -1. Okay, so we are going to execute this script, and you will see here in the silver layer appearing this data warehouse view. Okay, so these views here will become the source for the goal layer. Okay, so now what we have to do, we are going to populate our metadata gold. Okay, so we are going to insert into our main control table this data for the DIM product, all this data. Let me connect this, sorry, to the metadata framework. So for this last step, we are going to see the gold layer. We can see the 4 dimensions and the fact tables that we are going to insert, okay, using a full pattern. Okay, we can have more patterns here, incremental, the merge, in our gold layer. Okay, so let's go. We know we have created here a pipeline called PP Gold. So here it receives by parameters all the metadata information. If we need to do a merge, an incremental, a full, okay, we need to execute a store procedure at the end. Okay, so we have this kind of framework. We could add more things here. We can check our load type and add more pattern here, whatever we need. We can add that to our needs. And let's execute this last step. Okay, so we will go to our data warehouse orchestrator. Okay, let's deactivate this now, and let's activate only now the goal layer. So this last execution is going to populate our empty goal layer with the dimensional model, with the dimension tables and the fact tables. Okay, so while it is running, okay, we are going to see that it is reading the metadata. Okay, so while this is in progress, okay, let's see our goal layer. We are dynamically creating these tables. Okay, so all these tables that we have here, these fact sales, the customers, this is territory, that this our main control table. The pipeline, what it is doing is creating the tables here because the table does not exist. And with this logic, as you can see, we have the fact sales table, the team customer, the team product, the team salesperson. Okay, so all this data, we have our data warehouse with the fact tables and the dimension table. Okay, right. So we are a couple of steps to finish our architecture, our end-to-end solution. Let's see where we are again. So let's return here. We have all our golden layer is populated. Okay, so now it's time to build our semantic model. Okay, so here, as I have explained to you before, there is an important difference on the using the correct storage mode in this case. Okay, we can use the import mode, the direct query, and the new direct lake. Okay, we are not going to explain in this session the difference, but just for the demo purposes, okay, we can open from the traditional way of developing this is with the import mode. Okay, we are going to connect to our Fabric workspace, and we can model with Power BI Desktop, we can model our solution. Here we are going to build a blank report. It is open now, and we are going to connect to our Fabric workspace. Okay? We click on Get Data. We are going to connect to our Microsoft Fabric. We are going to connect to our warehouse. Okay, connect. We're going to connect to the goal layer. And at this point, it's important to explain this. Okay, so here we have the connect or the connect to the SQL endpoint. If we want to use the directly connection, we would use this connect. Okay, we would do this live connection, but this implies that we should model in the service. Okay, at this point, and if not, we can import the data in the SQL endpoint. This is what we are going to choose. We are going to connect, okay, and it is going to import all the data. Okay? So while we import all these, our bin tables, okay, these tables are imported, so we can load, and once they are imported, okay, we can model our solution. Okay, so you have to choose between the import and the direct query. We are going to use the import. And this is the traditional way of doing this kind of star scheme. Okay, we have our fact sales connected to the different dimensions. We have added a couple of measures, the number of sales order and the total sales. Okay, so in this case, we will publish this to our workspace. Okay, and we will see here, this is our Medallion. Okay, and our semantic model is here. Okay, so we have our semantic model in this folder called semantic models, and here we have this sales data map. Okay, once we have this semantic model available, we can connect with Power BI Desktop again and develop our visualizations. Okay, so we are going to open Power BI. we have finished with this. Okay, so now here we can connect to our semantic model. We have here the option, connect to the Power BI semantic models. Here we have our sales data mart, okay, available. And we have, as you can see, is a live connection to the model we have already deployed. We can drag and drop the different metrics, okay, and build, we can build a simple report and publish it to the service. In this case, this is the same. We have not changed anything. This process has not changed anything from the Power BI. This remains the same, okay? And this is going to publish this report. And inside Fabric, we will see this report appearing here, okay? So if we go to the data visualization at the end, we can see here the sales report that is here in the service, okay? In the next episode, we will talk about the organization of workspaces. Now everything, for simplicity and for demo purposes, everything is in the same workspace, okay? This is not the real scenario, but anyway, we have this kind of nice organization of all the things. We have explained all the things. We have created our metadata warehouse to store the metadata solution. We have created our pipeline to populate our bronze layer using metadata. The silver with this virtualization layer, and finally the gold layer with this pipeline that moves the data to the gold layer. At the end, we have created the semantic models and the reports, okay? So these are the wrap up and conclusions, okay? So this is what I have explained to you, what we have done today, all the steps. And just to the wrap up and conclusions, what we can learn from this session, okay? We have shown you a reliable framework thanks to this error reduction, because we are automatizing everything. We have seen the high performance of the copy activity thanks to this parallel execution, the simplicity of our solution to facilitate the maintenance and the troubleshooting. As you can see, it's adaptable and flexible framework that we can adapt to our needs. We have used the accelerators and Power BI all in the same platform, okay? So this integration lets us innovate faster. In Azure, we don't need to provision any other resource. Everything is in the data platform. And we have also seen the high flexibility to use all the variety of tools, code or low code, okay? We haven't demo using Spark notebooks, but we could do the same, accomplish the same with using Spark, for instance, okay? So this is all. So thank you very much. See you in the next episode.